So in the last class, we were solving linear equations. And if you observe, those linear equations had variable only on one side of the equation. For example, 2x plus 3 is equal to 5. When you write this equation, the unknown quantity, the variable, is only on one side of the equation. But it may not be the case always, okay? You will often encounter problems, linear equations having variables on both sides. So let us see how we can solve questions which involve variables on both sides. So our next idea is linear equations with variables on both sides. Say, for example, you have 7k is equal to 4k plus 50. Okay, so what is the idea here? So we have 7k on one side, we have 4k on one side. So the idea is you have to collect all those variables to one side of the equation and the constants, the numbers, to the other side. You have to collect variables to one side. All right. So the normal operation which you do on numbers can be done on variables as well. So how can you do it? You can bring this 4k to the other side of the equation. So you have 7k minus 4k is equal to 15. And 7k minus 4k is nothing but it's 3k. Okay, it's basically 7 minus 4 times k. All right, so 3k is equal to 15 and you have k is equal to 5. So that is the first point. So when you have variables on both sides of an equation, collect all variables to one side. It's simple, intuitive enough, right? You just convert it to a familiar form. And the familiar form is you have variable on one side, you have unknown, the numbers on the other side, right? Is this all right? Yes. Yes. Okay. Okay. And next thing is this next thing you need to note is sometimes you have to figure out to which side of the equality you have to bring the unknowns. Because, for example, in this question, you could have brought 7k to the other side. Okay, you could have brought 7k to the other side. Okay, then it would have been 0 is equal to 4k minus 7k plus 15. Right? Now 4k minus 7k is minus 3k plus 15 is equal to 0. Now let's take 15 to the other side. So it's minus 15 is equal to minus 3k. Right? Now you can get rid of the minus 3 by dividing throughout with minus 3. So you have k is equal to minus 15 divided by minus 3. The answer is 5 again. Right? See, you can solve this problem using this method, also using this approach. But obviously, the approach number 1 is much easier, right? And it's much more straightforward. And you like it much better when you have the coefficients of the variables as positive and not negative. Okay, when it is positive, it's much easier for you. At least in your mind, it's much easier, right? Right? So the idea is you need to figure out to which side of the equality you have to bring the variables. So in this case, it's pretty straightforward because, it's pretty intuitive that you have to bring everything to this side. So this works for you. Sometimes in some questions, you have to make a decision. Okay. You have to make a quick decision. I mean, it's not difficult. It'll come through practice, right? So you understand what I'm saying, right? Let's quickly do one more question. Yeah, suppose we have 3x minus 2 is equal to 6x plus 4. Right? So I'll do it. Please listen, please listen. So one way is you can bring 6x to this side, take minus 2 to the other side. So we have 3x minus 6x is equal to 4. And the minus 2 on the other side will be plus 2. So minus 3x is equal to 6. So you have x is equal to 6 divided by minus 3. Okay. 6 divided by minus 3, the answer will be minus 2. All right. On the other hand, you can do it this way as well. 3x minus 2 is equal to 6x plus 4. So I'm going to take 3x to the other side and 4 to the other side. So we have 3x here. Okay, I'll write the step. 6x minus 3x here. We have minus 2 minus 4 here. So that's like 3x minus 6. And we have x is equal to minus 6 divided by 3, which is minus 2 again. Okay, see, both methods are identical, right? But we feel more comfortable when the coefficient of x is positive. Okay. So that's all I wanted to tell you. Okay. So as far as possible, when you're taking the unknowns to one side, when you're collecting variables to one side of the equation, as far as possible, try to make them positive. Okay. So that is the second point. Cool. So we are dealing with equations. Okay, we are dealing with linear equations which have unknowns on both sides. We have variables on both sides. Okay, so the idea is to bring every variable, bring every unknown quantity to one side. Is this okay? Yeah, cool. And the third point I want to tell you is, sometimes when you have expressions divided, when you have a denominator on both sides of the equality, when you have denominator on both sides of the equality, you may have to cross multiply. You have to cross multiply. Okay, I'll tell you an example. Say we have 3x by 2 is equal to 18x minus 6 by 6. Okay, so the first step that comes to our mind is you have to make a cross multiplication. You understand how a cross multiplication is done? You just cross multiply. So we have 3x into 6 is equal to 2 into 18x minus 6. So this is 18x is equal to, you can distribute 2, that will be 36x minus 12. All right. Now take 18 to the other side, bring minus 12 to the other side. So 12 is equal to minus 18x. No, it's plus 18x. I'm sorry. It's plus 18x because 36x minus 18x is, I write that step. It's 36x minus 18x, which is 18x. So answer to our question is x is equal to 12 divided by 18. So you can cancel off the common terms. The common term is 6 here. You can cancel by 6 throughout. So it's 2 divided by 3. 2 divided by 3. So that is the another thing you need to note. Sometimes we need to cross multiply. Okay. But we need to also figure out whether to cross multiply or not. Because in some cases, you may be able to simplify the denominator before making a cross multiplication. For example, in this question. So is this fine? So far, so good. Is this fine? This approach is fine, right? I mean, it's okay for you. You already know how to do this. Please tell me if you're finding any. No, it's negative 12 here. See, it's negative 12 here. I'm taking it to the other side. So it becomes plus 12. It's 36x negative 12. It goes to the other side. It'll become plus 12. Robin, is it okay? See, essentially what we are doing is, in this step, essentially what we are doing is, you can add a constant term on both sides of the equality, right? So I'm basically adding a 12 on both sides of the equality, right? And here, this 12 and minus 12 gets cancelled off. These two goes away. That is how you have plus 12 on LHS. That is how we have plus 12 on the left-hand side of the equation. Cool? Is this okay? Yeah. And the next thing I want to tell you is, even before cross multiplying, you have to check whether the denominators can be simplified, right? So in this case, don't you think the denominators could be simplified? Don't you think the denominators could be simplified? Check again. See, I'll write the question once again. We have 3x by 2 is equal to 18x minus 6 divided by 6. Don't you think the denominators could be simplified? Yes. See, again, I'll give you two approaches. See, one way is you just cancel 2 and 6 here. What will be remaining? 3. And it will be 1 here. Right? Now you can cross multiply. So we have 3 into 3x is equal to 1 into 18x minus 6. So we have 9x is equal to 18x minus 6. Again, 6 is equal to 18x minus 9x. So 9x is equal to 6. Again, x is equal to 6 by 9, which is 2 by 3. This is one way. This is one way to simplify the denominator. What do you think will be the other way to simplify the denominator before you make a cross multiplication? What do you think will be the other way? What do you think? How can you simplify the denominator? See, in this approach, I cancelled off the common term on both denominators. Denominators on both LHS and RHS, right hand side and left hand side. What do you think will be the alternate approach? Just think. Again, such ideas do come through practice. Okay, practice only. So you have to practice a lot of questions. When you look at these questions individually, these are not easy. These are not difficult questions. These are pretty easy questions. But the idea in an SAT is to crack them in, say, 10 seconds, 20 seconds, 30 seconds, 40 seconds, right? Any clue? Any idea? Yes or no? Do you have any clue, any idea? I mean, how this can be simplified? This is one way. This is one approach. I hope this is fine for you. This works. Yeah. Okay. So the other approaches, listen to me carefully. We have 3x by 2 is equal to 18x minus 6 by 6. So, see, observe that in the numerator, you can take 6 as a common factor. Do you see that? In the numerator, you can take 6 as a common factor. Do you see that? Yes or no? Yeah. So this is essentially 6. If you take 6 out, it will be 3x minus 1 divided by 6. Cool. Now the 6 goes away. Now you can cross multiply again. So we have 3x is equal to 2 into 3x minus 1. So we have 3x is equal to 6x minus 2. Again, bring 3x to the other side, minus 2 to the left side. So we have 2 is equal to 6x minus 3x, which is 3x. So we are left with x is equal to 2 by 3. So this approach is also fine. Tell me. Is this okay? Yeah, cool. Yeah. See, why I'm telling you, see, the same question we did in 3 ways. This is one way, direct cross multiplication. Second method is you cancel off common terms from both denominators. See, you looked at both denominators. We have 2 here. We have 2 here and we have 6 here. So you cancelled the common terms from both denominators. In the first approach, you directly cross multiplied. Second approach, you are trying to simplify the denominators before making a cross multiplication. In the third approach, you cancelled off common terms from the numerator and denominator of a specific term, of a specific side. Yeah. So which approach will you use in an exam? I mean, why am I telling you the 3 approaches? Why am I teaching you 3 ways to solve a problem? Which method will you use during an actual exam? During the actual exam, suppose you are encountered with this problem, which method will you use? Just let me know your opinion. 1, 2, or 3. First method is direct cross multiplication. Second is first simplify the denominator. Third method is simplify the numerator and denominator of one specific side. Yeah, 1. See, if you approach all the 3 methods, it will take more or less the same time. Okay. But the method that you should be using during an exam should be the first thing that comes to your mind. Okay. Because you can't keep searching for a shortcut during an exam, because it's going to be another waste of time. So obviously, see, most of the time, a math problem can be approached in multiple ways. And what approach will you use during an exam? That method that comes to your mind initially. All right. Because, you can't see, you solve this problem halfway through and then you leave it and say, this is going to be lengthy, I'm going to look for a shortcut. That's not how it works in an exam, because there is time constraint. If you have started with this direct cross multiplication, go ahead and do it. Okay, no issues at all. But you should know all the methods, you should know all the tricks, you should know all the strategies. You should know how to approach a problem in multiple angles, from multiple angles. Because, we don't know which method will actually strike you during an actual exam. Okay. During an actual exam, maybe this will strike you. During an actual exam, this might strike you. Okay. So it's very important that you should know how to crack an exam from different approaches, using different approaches. All right. You understand my point? We are speaking from a test prep approach point of view. I hope you understand my point. Yes or no? Yeah. Yeah, cool. So let's do 1 or 2 examples and then we'll move on to the problem sheet from the previous class. Okay. Let's do 1 or 2 problems. So just try this question. We have 2k minus 5 is equal to 3 into 1 minus 2k. I'll give you an easier question first. 5x minus 2 is equal to 3x plus 4. Okay, that was pretty quick. Cool, very cool. Yeah. So you take 3x to the other side. We have 5x minus 3x is equal to 2 to the other side. 4 plus 2. 5x minus 3x is 2x is equal to 6. So we have x is equal to 3. See, you were able to do this in less than 10 seconds, right? Okay. But I'll tell you this, sometimes this question may show up as a calculator question, calculator section. So, there are 2 sections in SAT, calculator section and non-calculator section. Suppose this question shows up in the calculator section. Will you pick up your calculator? Will you pick up your calculator? No, don't do that. It will be tempting. See, that is the tricky thing. The question is not difficult at all. But if you're going to, if you are tempted to pick up the calculator, you're going to waste a lot of time. Instead of 10 seconds, you will end up taking maybe 30 or 40 seconds. Every second counts. Okay. Just yet another quick question. 2k minus 5 is equal to 3 into 1 minus 2k. Yes, very good. So we have 2k minus 5. Please listen, please listen. We have 2k minus 5 on the LHS, and when you see a bracket, when you see a parenthesis, what do? You have to distribute. It's basically a multiplication. You have to distribute. So it's 3 into 1 minus 3 into 2k, which is 3 minus 6k. You don't have to write down all the steps, okay? Some of this can be done mentally, and you should be in a position to do a lot of mental calculation in an actual examination. In school exam, maybe you have to write down all the steps. But our idea is to skip as many steps as possible because every second matters. In school exam, I guess I don't know how it works in the United States, but here in India, if you skip steps, you lose marks in school exams. Is that how it works there? I think it's the same all over the world. But in math, I mean, in a test prep, only the final answer matters. Okay, nothing else matters. Irrespective of how much time you spend on it, irrespective of how many steps you write, if you don't have the final answer right, everything is waste. Everything is a waste of time, right? So the number of steps are not going to matter. You have to minimize the number of steps. You have to do a lot of mental calculation. All right. So I'm going to take 6k to the other side. So 2k plus 6k will be, I am going to take minus 5 to the other side. It will be 3 plus 5. So 8k is equal to 8. And your k is 8 by 8, which is 1. Robin, is this all right? Yeah. Just one more question, and then we'll see an actual question from an SAT. After that, we'll move on to the problem sheet from the previous class. So we have 3 minus 5b plus 2b is equal to minus 2 into 1 minus b. I'm sure you would have seen a lot of questions of this kind in your school. But from an SAT perspective, you have to do it very quick with minimal steps. I don't think 3.5 is the answer. Just check once again. What about others? What are we getting? Uh-oh. Right. Everybody got different answers. Okay. Yeah, I'll do it. I'll do it. Okay. Listen carefully. I think Anjali has the right answer, but others would have made a slight small mistake somewhere. Can you recheck your work? Others, can you recheck your work? Okay, okay. Now, you got the final answer? Prisha, what is the final answer now? Is it 7/5? Olivia and Robin. Yeah. Okay. Now you understand one thing. I told you it's important to do it quickly, but it's also important to do it accurately because suppose this has options. They would have carefully given the options as you have 7/5, you will have -7/5, you will have 7/4, and you will have and another person has got 3.5. See, one guy will mark 3.5, one person will mark 7/4, one person will mark -7/5, another person will mark 7/5, and only one answer is right. You understand, right? So apart from the one right answer, there will be three wrong options given in the question. And those wrong options won't be any random stuff. Okay, they would have carefully crafted those wrong options. Okay, even if you make a small mistake, the final answer would have shown up in the options, right? So that is another important thing to note. Even if you make the slightest of the mistake, okay, that answer would have come up in the options, right? Okay, anyway, let's do it. So we have 3 minus 5v plus 2v is equal to -2. You expand, you distribute this -2, so it's -2. -2 into -b is going to be plus 2b, right? -2 into -b is plus 2b. -2 into -b is plus 2b. I hope everybody is clear with the concept. -2 into -b is plus 2b. See, -2, this is nothing but -2 into 1 minus b. So this is essentially -2 into 1 and -2 into -b. Or you can put bracket here also, no problem. Okay. Of course, here it means plus, right? So it's basically -2 plus -2 into -2b is 2b. Why is negation of a negation gives you a positive number? Why is negative of negative positive? Why is minus of minus positive? Why is that so? Why is that so? Why is negative of negative positive? Ever thought about it? Why do you think negative of negative is positive? I mean, do you generally accept it as a rule? I mean, just because your teacher told you or your textbook is telling you that negation of negation is positive, do you accept that as a fact? No, it doesn't work that way in mathematics. You know, right? It's not magic. Everything has a logic, right? So can somebody tell me why is negative of negative positive? Why is minus of minus is plus? What really happened when you negate a number? What really happens when you negate a number? Anybody? Anybody? What about others? Have you thought about it? Do you have an intuition on why negation of negation is plus positive? Never thought about it. Okay, cool. Just listen carefully. See, the numbers can be represented on a number line. 0, 1, 2, 3, 4, 5, -1, -2, -3. You're familiar with the number line? It's an easy way to you can just visualize the numbers. Number line is an easy way to visualize the numbers. You have seen the number line, right? Yeah. Yes or no? Yeah. So when you negate a number, see, suppose you are sending the number 2 into the negation operation. So this is the negation operation. You can imagine this as an input and it gives -2 as the output. Right? So you can think of it as a black box. And if you give 2, it will give you -2. If you give 3, it'll give you -3. Okay. If you send 3 to this box is going to give you -3. Now my question is, if you send -3 to this box is going to give you 3 as the answer. Okay. Why does it work that way? That is my question. So we really need to know what this black box is doing. Okay. So all these years we have been using the black box without actually knowing what it was doing. Right? So I'll tell you what exactly is happening when you're negating. Okay. So when you're negating 2, when you negate 2, you get -2. And you know what is really happening? This 2, you're basically rotating this 2 about origin in a semicircle. Okay. You're basically rotating 2 about origin in a semicircle. Right? About origin means what? The distance from origin will be kept the same. You have 2 units to origin here. Here also you have 2 units. So just imagine origin as the center of a circle and you're rotating the number 2 to reach -2. So what is the geometrical understanding or the intuitive understanding or the visualization behind negation operation? It's basically you're rotating that number on the number line. Got it? In a semicircle. Is this all right? When you're negating, what you're actually doing is you're basically rotating that number on the number line in a semicircle about the origin. Is this okay? Is this okay? Now, when you're negating 3, again, what is the idea? You have to rotate 3 and it lands up at -3. When you negate 4, what happens? You're basically rotating rotating 4 about origin and it lands up at -4. Got it? Is it okay? So what have we figured out? What did we figure out from the discussion we made so far? We understand that negating a number or multiplying a number with -1 is as good as rotating that number in a semicircle. Is this clear? Is this okay? Negating a number is as good as rotating that number in a semicircle. Cool? Okay. What about others? Is it confusing? No, I'm just saying what is happening behind inside this black box. what this black box is actually doing when you're negating a number. This black box is taking your input and then it is rotating the number on the number line and giving you -2 as the output. That is what is happening. I mean, for your understanding, intuitive understanding, you can think of it this way. You're basically taking the number 2 and you rotate it on the number line and give back -2 as the answer. That is what happens when you negate a number, when you multiply a number with -1. This is okay? What about others? Yeah. Okay. And the direction is important. You're rotating it in the anti-clockwise sense. Okay. You're rotating it in the anti-clockwise sense. Yeah. Now tell me what happens when you apply the same principle to the numbers on the negative numbers. What happens to the negative numbers? Tell me what happens to the negative numbers. Do the same thing. Do the same approach to the negative numbers. What happens? What happens to the negative numbers? You see, the -2 lands up at 2. -3, when you negate it, lands at 3. And -4 lands at 4. Of course, again, it's the anti-clockwise rotation. So what did I say? Multiplying a number with -2. So 2 into -1, or negating the number, you get -2. But what is it? What is the essential process that is happening? The geometrical interpretation of the process. Of course, geometry is much more easy to understand. So geometrical interpretation is you're rotating that number above the origin. So one multiplication with -1 is one rotation in a semicircle. So when you're multiplying it with -1 again, what happens? You're coming back to the same point because you're completing one full circle. You're completing one full circle. All right? Because you're rotating in 2 semicircles, which means you're completing one full circle. Is this okay? Okay. So you have an intuitive understanding why negation of negation is positive, right? Because a negation, negating a number or multiplying it with -1 is actually rotating the number about origin in a semicircle or in 180 degrees. You can say 180 degrees, semicircle. Okay. So when you're multiplying a number with -1 2 times, or when you're negating a negation, it's essentially rotation in 2 semicircles, which is rotation in a full circle, which means what? You're coming back to the starting point. You're coming back to the starting point. Okay. See, this explanation is important because in higher classes, you learn something called complex numbers. I don't know whether you have already learned about complex numbers. Have you learned about complex numbers? Anyone? Have you learned complex numbers? Complex numbers? Imaginary numbers? Imaginary numbers? No? Oh, you have learned complex numbers. Mm-hmm. Yeah, imaginary numbers. Imaginary numbers. You learn complex numbers. And you will soon realize that you can apply the same principle to complex numbers as well. Okay. You can apply the same idea to complex numbers as well. Basically, say take any number in the 2D plane. Take any number. Say, for example, we have 2, 3 here. You have 2, 3 here. Okay. What happens if you rotate this number in a semicircle about origin? Same logic. You will end up at -2, -3. Okay. You will end up at -2, -3. You will end up at -2, -3. Okay. You keep this distance same. OA, OP distance being same. All right. So this rotation concept I just told you will work for numbers in the 2D plane, as in the complex numbers as well. This number will be of the form 2 plus 3i. For those of you who are familiar with complex numbers, this is 2 plus 3i, and this number is going to be -2 minus 3i, which is minus of 2 plus 3i. Okay. If you have if you're not familiar with complex numbers, forget about it. No issues. You will soon learn about it. You will soon encounter complex numbers. Okay. So don't worry about it. I just wanted to give you an intuition on why negation of, see, everything in mathematics makes sense. Everything has some logic. You don't have to blindly believe anything. You don't have to believe something. You don't have to say blindly mug up stuff just because the teacher tells you to do so. Okay. All right. Everything has some sense. Everything can be understood from the basic ideas. Anyway, coming back to our question. So this was a question. Yeah. See, on the LHS, we have 3 minus 5v plus 2b. On the RHS, we have -2 plus 2b. Now, you can cancel this 2b off. You can cancel this 2b on both sides. Right? Now, what do we have? We have 3 minus 5b is equal to -4. And we have, take -4 to the other side, it becomes what? 7. And 5b to the other side, it's 5b. So we have b is equal to 7 divided by 5. Is this all right? Yes. Everyone? Olivia, Prisha, Robin. If you have any difficulty, do let me know. The only tricky part is you have to distribute this -2. There's a distribution happening. All right. Robin, I hope it's fine. Are you with me? Hello. I could have combined the like terms. See, I could have combined the like terms, but I didn't. I chose not to do it. Okay. I could have done that way as well, but I chose not to do it. And what really happened? What happened? In the next year, magically, see, the 2b got cancelled. I got lucky. That's all. I could have combined those like terms, -5b and 2b on the LHS. I could have done that. Okay, that way also I could have done it. 3 minus 5v plus 2b is equal to -2 minus 2, 1 minus b. I could have done the C. 3 minus 5b and 2b is going to be minus 3b. And on the other side, it's minus 2 plus 2b. So we have 3 minus 3b is equal to minus 4 plus 2b. Okay. Bring 3b to the other side, we have 5b. Bring minus 4 to the other side, we have 7. So we have b is equal to 7 divided by 5. I could have done this way as well, no issues. Cool. Okay. Let's do one real SAT question. Oh my God, time is running out so quickly. We digress in between. Let's do one real question. I'm sure you'll definitely feel comfortable doing this question now. Just this question. Robin, please be a little more careful because I think you have made a small mistake. See, it's essentially when you distribute this, you have to distribute here. So it's 2p plus 2 plus, again, distribute here. It's 8p minus 8 is equal to 5p. Okay, so this is 2p plus 8p, which is 10p. 2 minus 8 is minus 6 is equal to 5p. Take 5p to this side, we have 5p is equal to 6. And we have p is equal to 6 by 5. Okay, this is a grid type question. So you have to actually mark this answer in a grid. Okay, there are no options to be marked. You have to mark this answer in a grid, either as 6 by 5 or as 1.2. Robin, did you figure out where you made the mistake? Did you figure out where you made the mistake? Yeah, okay, cool. I have, can I take 2 more minutes? 2 more minutes? I'll just start off with the discussion of the problem sheet and then we'll continue in the next class. I'm very sorry. We have run out of time. I seriously feel that this 1 hour is not sufficient. I mean, when you do math, time flies. I'll just get started with this, okay? Then we'll see in the next class. So this was our sheet number 3. Yeah. The first question is straightforward, right? You don't want me to do it, right? And if you have any difficulty, do let me know. Again, the second thing is, it's again pretty straightforward. Yeah, I'll come to that. I'll come to that one by one. No issues, Prisha. We will see all the problems. Okay, we'll go through all the problems. Okay, if those if these are very easy, then only we'll skip it. Okay, the second one, shall I skip it? Yeah. In the third one, see, I have a asterisk here. So, which means it has an alternate solution. Okay. Third problem, how did you do it? As per solution, you can actually find A. Is it A or alpha? It's A. See, look at the question number 3. Question number 3. Prisha will come to 6, okay? But we'll do it in the serial order. Fine, right? Yeah, if 3 alpha plus 12 is equal to 30, what is the value of A plus 4? That is the question. So I hope, I guess you have done it in this way. You have first found out A, then found out A plus 4. Is this how you've done? What about others? Olivia, Robin, Anjali. Is this how you have done? Yeah, but there is a shortcut. See, we have 3A plus 12 is equal to 30, and what they have asked for is A plus 4. Do you realize that you can take 3 out from this? You can take 3 outside, and it is going to be nothing but 3 into A plus 4 is equal to 30. And you quickly have A plus 4 is equal to 10. You don't have to actually find out A. Cool? Did it strike? When you're solving it, did this strike you? No. In that case, you should know this. Okay, you should know such tricks. That is the point of our classes, SAT discussion, because even a few seconds, even the 5 seconds you save from such shortcuts will matter. This is clear, right? This method is clear. Clear. Yeah, cool. Okay, anyway, we'll continue in the next class, and I promise I'll complete this sheet in the next class. That'll be the first thing that we'll be doing in the next class. We'll complete this sheet, and I'll send across a sheet for the current week as well. All right. So don't worry, I'll discuss all the questions. Nothing to worry. Okay, Prisha will see all the questions. Meanwhile, if you want to give another try, if you find more time, and if you want to give another try to the sheets, no problem. You can go ahead and do it. But rest assured, we'll be doing these questions. You don't have to worry, okay? We'll definitely discuss all these questions. Of course, there are solutions provided, but apart from the solutions, there will be some tricks and some alternate solutions involved. Okay, I really want to emphasize on those things as well. So I'll definitely discuss those questions. And this 1 hour is, I think this goes away this flies. This time flies. Okay, anyway, see you in the next class.